Problem number 3 says if x and y are even numbers, and if z is 2x squared plus 4y squared, then the greatest even number that must be a divisor of z is what? So x and y are even numbers. There are too many even numbers for us to test to try to plug in for this. But we're looking for the greatest even number that has to be a divisor of z. So one thing you should know about even numbers, an even number is either created from 2 times an even number or 2 times an odd number. For example, 2 times 3 gives us an even number 6, and 2 times 4 gives us the even number 8. So every even number is either 2 times an even number or 2 times an odd number. So that's going to be important for us down the road here. But anyway, that's one thing we need to understand about even numbers. Not only are even numbers multiples of 2, but even numbers have to be either 2 times an odd number or 2 times an even number. So we're going to let x be 2 times some number m. It could be even or it could be odd. And that's important here. And we're going to let y be equal to 2 times n, with the same constraint that n can be either even or odd. Again, that's going to make a difference. It's not enough that a number is even. We're going to need to be able to know whether it was even because it was 2 times an even number or 2 times an odd number. If it was 2 times an even number, then it would at least have a factor of 4 in there. But if it's 2 times an odd number, we're only guaranteed to have a factor of 2 in there as the largest even number. Now it could be more, but we're only guaranteed to have that. So we're going to rewrite the expression or the equation with x equals 2m and y equals 2n. And so we get z is equal to 2 times the quantity 2m squared plus 4 times the quantity 2n squared. When we square inside parentheses, we get z is equal to 2 times 4m squared or plus 4 times 4n squared. Multiplying that out, we get 8m squared plus 16n squared. At this point, we could factor out an 8. And since z is a number that is 8 times some other number, then 8 is a divisor of z. 8 is a factor of z, and since it's a factor, it's also a divisor of z. It also evenly divides z. So far we know that 8 is a possible answer. And we know then that 2 and 4 cannot be answers. So it's either 8 or 16 here. So this is where we have to get back to whether m and n are even or odd. And the first thing we have to look at is when you square an even number, you always get an even number in return. For example, 2 squared is 4, 4 squared is 16, 6 squared is 36. So any even number squared always gives you an even number. On the other hand, any odd number squared always gives you an odd number. For example, 3 squared is 9, 5 squared is 25, 7 squared is 49. Now, of course, this isn't proving anything. We're just seeing patterns here, and we're making assumptions that they're all going to behave that way, when in fact we haven't established that via technical proof yet, and we're not going to for this. But what that tells us is that the first term in parentheses, m squared, could be odd if m is odd, and it could be even if m is even. We really don't know that for sure. But the second term, 2n squared, will always be even. N squared could be even or odd, depending on whether n is even or odd. But once we multiply 2 times that even or odd number, we're always going to get an even number out of it. And the last thing we want to look at is that when we add 2 even numbers together, we get an even, but when we add an even and an odd number together, we get an odd number. For example, 2 plus 3 is 5, 2 plus 4 is 6, 2 plus 5 is 7. And so if m squared is odd, then m squared plus 2n squared will be odd. If m squared is even, then m squared plus 2n squared will be even. And we don't know for sure, since it might turn out to be an odd number. That odd number may not have another factor of 2 in it. Whereas if it was an even number, it would have another factor of 2, and we could bring that out also. But based on what we know, 8 is going to be the greatest even number that is a divisor of z.